This is the video over section 6.6 about trapezoids and kites. I'm starting on page 389, and let's read the definition for a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, y'all, we've been talking a lot about parallelograms, and I want you to realize that parallelograms, going back to this chart that we keep using, they had two pairs of parallel sides. Both sets of opposite sides were parallel, so these two and these two. But a trapezoid says it has exactly one, no more, no less. So a trapezoid is not a parallelogram. These 5 things that we've been talking about with parallelograms, they do not apply to trapezoids. There are some new terms we need to talk about for trapezoids. That one pair of parallel sides, those are going to be called your bases. So this will be a base, and this will be a base. And then the other pair of sides that aren't parallel, those will be your legs. So that's a leg, and this is a leg. Even if your trapezoid is kind of rotated, these two are still your parallel sides, so they are your bases. That's a base and this is a base. And then the two sides that are not parallel are called your legs. That's a leg and that's a leg. Now, your angles that share a base, those will be called your base angles. So in trapezoid ABCD, angles A and B share this base, so they are a pair of base angles. Angles C and D share this base, so they are another pair of base angles. Now, sometimes you're going to have a very special trapezoid called an isosceles trapezoid. We're going to talk about these a lot in this section. Isosceles trapezoids are a lot like isosceles triangles. Remember, in an isosceles triangle, your two legs were congruent. Well, in an isosceles trapezoid, your two legs are also congruent. We've got a couple special theorems for when you have isosceles trapezoids. So let's look at theorem 619. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So we've got an isosceles trapezoid here because we have one pair of parallel sides. We have a pair of congruent legs. So these two base angles will be congruent, and these two base angles will be congruent. And y'all, this only happens in an isosceles trapezoid. It's not just in any trapezoid. Your legs have to be congruent for your base angles to be congruent. Okay, one more thing about trapezoids. And this is good for any trapezoid. It doesn't have to be an isosceles one. You've got two pairs of parallel segments or lines and a transversal that cuts through them. So remember from chapter 3 or chapter 4, we talked about anytime you have parallel lines, you need to think alternate interior angles, alternate exterior, corresponding, same side interior. So what you have here are same side interior angles. Two parallel lines cut by a transversal. These are same side interior. So these will be supplementary. Now, if it's an isosceles trapezoid, remember your base angles will be congruent, but these two angles will still be supplementary, and so will these two. Okay, let's look at the got it on page 390. You can work problem number 1 on your own. It's all worked out there for you. But let's look at the got it. It has trapezoid PQRS, and it's an isosceles trapezoid because your two legs are congruent, and you have these two bases that are parallel, of course. So if this angle measures 106, they want us to find the missing angles. So because this is an isosceles trapezoid, you know that this angle will also be 106. And these two angles will be congruent to each other because they're another set of base angles. They share a base. So we'll use the same side interior angles. These two will be supplementary. So this one is 74 degrees and this is 74 degrees. So that's how you can find your missing angles. I don't know if you can hear them fighting or not. I have kids upstairs arguing. Okay, so I want you to read problem number 2 on your own and work it. And then there's another theorem I want us to look at, theorem 620 on page 391. It is also for isosceles trapezoids. If a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So again, you have to have an isosceles trapezoid, and when you do, your diagonals will be congruent. Now, we've talked about other quadrilaterals that have congruent diagonals. I'm going to flip back over to this chart we keep going to. Remember, a rectangle has congruent diagonals, and a square has congruent diagonals. But these are parallelograms, and remember, a trapezoid is not going to be on this chart because it is not a parallelogram. But still, if you have an isosceles trapezoid, its diagonals will be congruent. Okay, I also just want to pause for a second and say that if you are watching this video, if you will email me and tell me that you watched the video and you heard my kids arguing, I will give you 20 extra homework bonus points, just so that I know y'all watched it. Okay, so to sum up, isosceles trapezoids, they have congruent legs, their base angles are congruent, and their diagonals are congruent. Okay, we have another theorem for trapezoids. It is not only for isosceles trapezoids, but for any trapezoid. Go upstairs. Okay, it's theorem 621. It's called the trapezoid midsegment theorem. Now, y'all, we had a midsegment theorem for triangles, and I just want to review it for a second. It was for triangles, and remember it said if you had a midsegment, a segment that connected two midpoints, like D is the midpoint of this side and E is the midpoint of this side, I know because of those congruent symbols, then DE will be parallel to MN, and it will also be half the length of MN. So you know that DE would be 10. Okay, so the trapezoid midsegment theorem says if you have a trapezoid, can be any trapezoid, doesn't have to be isosceles, you know that the midsegment will be parallel to the bases, so MN will be parallel to RA and TP, and the length of the midsegment is half the sum the lengths of the bases, so MN will be half of the length of RA plus TP. So let me just draw this here. Let's say that they tell you that MN is a midsegment, and they tell you that RA is 7 and TP is 13. So MN will be 1/2 of 7 plus 13. You add up the two bases. I know these are bases because they're parallel. You add up the two bases and you cut them in half. So MN will be 1/2 of 20. MN will be 10. So it's different from the triangle theorem because the triangle was just half the third side. For the trapezoid, it's half the sum of your two bases. So you have to add those together. Okay, I want you to read problem number 3 and work it out on your own because it's worked out in the book for you, and you can look at that for a reference if you need to. But let's do work the got it. The got it number 3 is on page 392, and I have it drawn out here for you. And they tell you that MN is a midsegment of trapezoid PQRS. So I know that this is a midsegment. It's not labeled in my picture, but they stated it in the problem, got it number 3. So because of that, I know that MN will be 1/2 the length of QR plus the length of PS. So QR is 10, and the length of PS is 8x minus 12. I'm trying to find x. That was the first thing they asked for and got it number 3. So MN is 2x plus 11. It will be 1/2 of 10 plus 8x minus 12. I'm just going to add up my two bases. So this will be 8x minus 2. I'll multiply that by 1/2 and distribute. So I'll subtract 2x's from both sides and add 1. So 2x will be 12 and x will be 6. So I found x. The problem says what is x and what is the length of MN. So MN was 2x plus 11. So I'll substitute 6 in there. MN will be 12 plus 11, or 23. Okay, so that's everything about trapezoids. You need to know that the mid-segment is half the sum of the bases. You need to know that the two base angles are congruent. Both sets would be, so base angles are congruent, and you'll have two sets of base angles in your trapezoid. And you need to know that diagonals are congruent. Okay, now we're going to talk about kites. This is on page 392. A kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. So if you draw it, let's just look at it here. See how your two consecutive sides are congruent, but your opposite sides are not congruent. So again, this is not going to be a parallelogram, because in a parallelogram, your opposite sides are congruent. This is just going to be a quadrilateral. It's not special like a parallelogram. Okay, so some, excuse me, we've got a theorem about kites. If a quadrilateral is a kite, then its diagonals are perpendicular. So here we've got a kite because it has two consecutive sides that are congruent and another two consecutive sides that are congruent, and no opposite sides are congruent. So its two diagonals are going to be perpendicular. They're going to form a right angle. And again, this happened for rhombuses. When you had a rhombus, those diagonals were perpendicular. But a rhombus was a parallelogram, and these things aren't parallelograms. Okay, I want you to read the proof of Theorem 622 in your book. And I want us to work problem number 4 together. Excuse me. So I have it drawn out. They want us to find the missing parts, missing angles 1, 2, and 3. And they've told us that this figure is a kite. Because it's a kite, you know that these consecutive sides are congruent and these consecutive sides are congruent. We also know the two diagonals will be perpendicular, so you automatically know the measure of angle 1 is 90 degrees. And you can figure out the measure of angle 2 because if this is 90, Cole, please go to your room. Leave Claire alone. If this is 90, well, you've got a little triangle in here. So 90 plus 52 plus the measure of angle 2 will equal 180. So I think the measure of angle 2, I'll subtract 90 and subtract 52. I think it'll be 28 degrees, 38 degrees. Okay, we still need the measure of angle 3, so I want you to watch this. Y'all, I'm going to break this down into two triangles. This one and this one. These two big halves, two big triangles, they are congruent by side, side, side. See how this set of sides are congruent and this set of sides are congruent? And here, DF is going to be reflexive to itself. So it is congruent to itself, and you have side, side, side. So angle 3 right here will be congruent to 52 degrees by CPCTC. Okay, let's quickly work got it number 4, and then we'll be done. Okay, again, they tell you that you have a kite, that quadrilateral KLMN is a kite. So because of that, I know that these consecutive sides are going to be congruent to each other, but no opposite sides are congruent. I also know that the measure of angle 1 is going to be 90 because your diagonals are perpendicular. So if this is 90,
Roscoe, hush.
Okay, here's another chance for extra credit. What did I say? 20 points for telling me that my kids were fighting. Then I'll give you another 20 points for telling me that my dog's name is Roscoe and he was barking. Just so you get credit for watching the whole video. Okay, so you're going to have another set of 2 congruent triangles right here. Because these 2 sides are congruent, and these 2 sides are congruent, and this KM is congruent to itself. It's going to be reflexive. So do you see triangle KLM is going to be congruent to triangle KNM? Because of that, the measure of angle 3 will be 36 degrees. We already said the measure of angle 1 is 90 because your diagonals are perpendicular. This will also be 90. So 90 plus 36 plus the measure of angle 2 will equal 180. So what's this? 126 plus the measure of angle 2 equals 180. So 54 degrees will be the measure of angle 2. So we have the measure of angle 1, measure of angle 2, and measure of angle 3. Okay, there's a good little chart here for you to look at. It breaks your quadrilaterals down into the parallelogram, which has a rhombus, rectangle, and square. And then we talked about trapezoids and the isosceles trapezoids. Remember, isosceles trapezoids have congruent base angles and their diagonals are congruent. And then we also talked about kites that had perpendicular diagonals. So y'all do your Math Excel homework. Let me know if you have questions, and remember to email me those 2 things so I can give you credit for watching this video. I hope y'all are enjoying your snow day, and I will see you soon.